Hi there. Today I'm gonna talk about some principles and concepts about geomechanics. So to know what are we going into, let's define what is the geomechanics. Then it refers to it's a branch of the geophysics and the geoscience that it's gonna focus on the geochemical behavior of how geological materials, particularly the study of how the rocks and soil respond to various physical forces and stress, and it involves the understanding of the deformation, the strength, the stability of earth materials under different conditions such as the pressure, temperature, and others. So, in all formation penetrating during the drilling of a well-contained pressure that which may vary in magnitude depending of the depth, the location, and proximity to other structures. So, in order to the nature, extent, and the origin of the formation pressure is necessary to define and explain basic wellbore pressure concepts. So, como primero vamos a definir entonces estos conceptos que van a ser la porosidad, permeabilidad, la compactación, la sobrecarga y la presión de sobrecarga para que lo que les decía, entender un poquito de en qué nos estamos metiendo dentro de la geomecánica. Okay, so the porosity, it's gonna refers to the percentage of the empty space or voids. Voids hace referencia al vacío. Ok, entonces quedamos que la porosidad va a ser el espacio vacío que hay entre los granos de roca. Bien. Mientras que la permeabilidad, va a ser la facilidad con la que los fluidos pueden fluir entre estos granos de roca. It says that the permeability is the easy way in which the fluids can flow through the rock. So for the compaction, we have that it refers to the process by which lost sediments become more densely packed over the time due to the weight of the overlying layers. And as layers of sediments accumulate, the pressure from the upper layers are gonna squeeze these lower layers, forcing out the air and the water. So this process leads to a reduction in the volume of the sediment, and it will increase the density, okay, and decrease the porosity in function of the tip. So in the figure that we have here in the stage A, there is a system that is containing water. And over and above, they have plates and springs. Oh, these are the springs, okay? So in the figure A, we have a system that is over pressure. And why I say that it's over pressure? Well, because there is no escape from this water. And so to the stage B, we have that the water is allowing to escape from the system. Okay? There is escaping from the system. So the plates are moving downward slightly. It means that the system is compacting and the springs are carrying part of the applied load. And as more and more water is allowing to escape from the system in the stage C, for example, we have that the system is the springs of the system are going to carry a greatest share of the load, which it's gonna result in the compaction. Bueno, y si se los explico de manera general, en un medio donde tenemos fluido y granos de roca. El primer escenario decimos que está en una sobrepresión, por ejemplo, porque no hay fluido escapándose, que bueno, más adelante lo voy a explicar un poquito más. No hay fluido escapándose, entonces si pasamos al siguiente escenario, al fluido se le está aplicando una sobrecarga de los sedimentos, los sedimentos que se están acumulando arriba, por encima. Entonces, esto ocasiona que los fluidos escapen y entonces, por lo tanto, los granos de roca van a hacer que se compacten más. Bueno, van a ocupar el espacio que fue retirado del agua. Y entonces, a mayor sobrecarga, mayor espacio van a ocupar. Lo que da resultado como la compactación. Pasando, bueno, entonces ya vimos que la compactación está en función de la sobrecarga, ¿ok? Y para esto nos referimos a la presión de sobrecarga, que es the overburden pressure, and it's the pressure exerted, la presión ejercida by the total weight of the overlying information about the point of interest. For example, in a given area, the overburden gradient is not constant, so with the dip due the variation in formation density. So this results from the variations of the lithology and the pore fluid densities, and in addition to the degree of compaction, whose formation density increases with the dip due to increasing the overburden. Les decía que la presión de sobrecarga, pues sí, está en función de la presión respecto a la profundidad, pero esta no va a ser como constante, ¿ok? Porque a mayor profundidad, pues van a variar. O sea, esta tendencia no iría así, sino que iría así, ¿ok? Okay, and what are going to be the pore pressure, the normal pressure, and the abnormal pressure? So we are gonna define each one, okay? So the pore pressure, it gonna refers to the pressure exerted by the fluids within the pores or void space of a geological formation such as the rock or sediments. The elevated pore pressure can impact the stability of the geological formation and may lead to issues such as wellbore instability in drilling operation. A normal pore space refers to the pressure of fluids such as the water or another odor that within the pore or the void space in the geological formation under a normal or ambient condition. This pressure is typically influenced by a weight of overlying rocks and sediments. So normal pore pressure, it's gonna be often used as a reference point for evaluating if there is an abnormal or overpressure condition. So overpressure can occur when the pore pressure is a geological formation. It's higher than the normal pore pressure. Then we can call it as also like abnormally high pressure. And if it is above, it's an abnormally low pressure. Okay, so this abnormal pore pressure, we also call it overpressure or geopressure, and it refers to the condition in which the pressure of fluid within the pore or void space of a geological formation. Okay, and what it's higher are going to be the pore pressure, the normal pressure, and the normal pressure. And for this condition, we can see each one. Okay, it gonna implicate the pore pressure of the wellbore stability, the drilling safety, and the hydrocarbon reservoir behavior. And this excess of pressure is the reason why the surface control equipment, like BOPs, are required when there is drilling oil or gas wells. Also, this abnormally poor pressure can occur at any depth, ranging from only a few hundred feet to high depths. This cause of the abnormally poor pressure, it's gonna be attributed to a combination of various geological, chemical, geothermal, and mechanical changes. Okay, so we are going to see what these abnormally high formation pressures are associated. But first, in this figure, to understand it better, we suppose that we have here shales in this formation, and if the shales have they have these little pores or less permeability, the fluids cannot pass through. Okay, so what trend line we going to have? This is the normal. Okay, the shales. This is the trend line normal we have in the normal pore pressure, and then we pass the overburden. Okay, so we have this dynamic that what will cause if we, for example, we have a salt dome or a fault. The same thing is going to pass. Okay, so explaining more, the salt that we have in the formation, it have a plasticity move upward, so the buoyant salt structures that pierce through the overlying sediment of rocks, we have that as the salt rise, it can create located pressure abnormalities to the compaction and the formation of the adjacent rocks. Okay, and as salt bodies can create overpressure zones in surrounding formation, as the salt moves and deforms, they're gonna trap the fluids. Okay, so the movement of the salt can cause faulting and fracturing also in the surrounding rocks. Okay, and to the earthquakes, it's gonna be the same thing because it's gonna make a faulting, and the faults and the fractures can act like a conduit for fluid migration, leading to the locating increases in pressure. And similarly, the failure on sealing rocks can also allow the fluids to migrate. But in this case, when they have abnormally high pressure, is because that is not allowing to the fluids to escape. So, to the osmotic phenomena, I have this diagram or figure where it basically an osmotic pressure, it's gonna rise when two solutions of different concentrations, because we have fresh water here and saline water or brine that are separated by permeable membrane. Okay, it could be clay or it could be shells even too. Well, I was saying that two solutions are separated by the membrane, and irrespective from a mechanism by which the semi-permeable membrane operates, the final result is the same because the osmotic flow continues until the chemical potential of the dissolution component is the same of both sides of the barrier. So, of an importance of the abnormally pressure geologic environment in this consideration that if flow is directed into a closed volume, the pressure inside necessarily increase until the equilibrium conditions are obtaining. Okay, so it also can be described as the spontaneous flow of water into a solution, or as the flow from a more diluate to a more concentrated solution when the two are separated from each other by this situable membrane. Okay, entonces, bueno, básicamente lo que me quería referir es que vamos a tener dos soluciones bueno, en este caso es un contenedor, pero si lo tuviéramos en una formación, tenemos dos soluciones y hay una membrana que lo está separando, que es semipermeable. Entonces, en un lado tenemos agua y en otro una solución salina con aniones y cationes, en donde este fenómeno osmótico lo que va a referirse es que van a tender a generar un equilibrio en donde en ambos lugares o espacios tengan la misma concentración o solución de sus componentes. Y esto pues hace que se generen, disminuyan las presiones y incrementen del otro lado. Okay, so another commonly formation pressure is the diagenesis phenomena, that basically is the post-depositional alteration of sediment, and it's constituted by minerals that where this process of diagenesis is going to include formation of new minerals redistribution and recristalización y redistribución de los minerales, la generación de nuevos minerales y la litification. The genesis. Okay, so to pass into the fracture pressure, la presión de fractura, que va a ser la presión requerida para fracturar la formación, y el esfuerzo va a estar relacionado con los esfuerzos mínimos horizontales de que va a ser la presión necesaria para abrir una fractura preexistente en la formación. Okay, so we have that the minimum stress models, okay, que son los modelos basados en el esfuerzo mínimo. That it means that these models are not considered the stress of the rock. It says that it means that they are going to represent the pressure needed to open and extended fractures pre-existent, and however, if it is already an open fracture, the stress minimum is going to be less. Okay. For example, we had stress minimum, stress maximum, where the pressure fracture is going to be bigger than the stress maximum, and the stress maximum is gonna be bigger than the stress minimum, and this is gonna cause this phenomena. Or en este caso donde los esfuerzos cambian, ok, por ejemplo, si tenemos que en esta cara, esta es mayor a esta, ok, el esfuerzo que se está ejerciendo es mayor que esta, y esta a su vez es mayor que esta, pues la fractura inducida se va a crear en esta configuración. Y en la otra, si el esfuerzo máximo que se está dando está en esta cara, es mayor con respecto a esta, pues tendrá una configuración de esta forma. Ok, entonces todo esto va a depender mucho de la magnitud, de los tipos de esfuerzo, y cómo se generará para que posteriormente sea calculado en los modelos de esfuerzo mínimo, ¿ok? Porque para definir por anticipado la resistencia de estas fracturas, pues se llevan a cabo pruebas de integridad a la presión de ciertos metros bajo cada punto de asentamiento de tubería de revestimiento mediante el bombeo de fluidos de perforación con el pozo cerrado para que puedan generar presurizaciones. Bueno, y esto ya va a corresponder a pruebas de integridad, or as known as well integrity test, that they are like the intermediate or production wellbore selection when they are drilled or cased and cemented with steel tubular pipes. They are gonna to provide the required well and barrier integrity demanded to safely protect the well from failing during its instant life cycle. So the planning, design, and engineering of each wellbore section is decided through determining and evaluating an optimal safe setting deep range of how this shallow of how deep it can be set. So in the primary purpose of this formation integrity test, that is the FIT or FIT, it's to evaluate how the persistence of the extent of any leaks or breaches in the wellbore, the casing, or the surrounding geological formations. So to the pressure may increase to the access of the maximum pressure that the wellbore or formation can withstand without failure. Okay, so this formation integrity test, it's very important to help identify how potential issues early into the drilling and completion of the process, allowing for corrective actions to be taken before the production begins. En una prueba FIT tenemos esta configuración, que son pruebas en las que en la mayoría de los casos la formación es presurizada. Entonces, presión. Se evalúan respecto al tiempo. Entonces se presuriza la formación hasta que alcanza su máxima presión que va a ejercer el fluido en estado dinámico para pues terminar la etapa que se va a perforar. En una prueba LOT, que es a leak-off test, we have that it helps to determining the pressure at which the formation begins to break or leak off. Okay, so the mud is pumped into the well at the controlled rate, where it's going to increase the pressure into the wellbore. So the goal is to gradually increase the pressure until the formation begins to break down or fracture. This formation is also crucial to the well stability, the casing design, and to prevent how the issues of the well. Esta es una prueba de goteo que básicamente hace lo mismo, pero, o sea, vamos a llegar a una presión de integridad de la formación, que es cuando estamos presurizando y luego aún así seguimos generando presión en la formación hasta que llegamos a un punto de goteo o filtración del fluido de perforación, en lo cual se puede observar al cambiar la pendiente. Cambia la pendiente, ok, y aquí ya es desfogue, aquí también es desfogue. Ok, para lo cual se puede observar cambia la pendiente en función de la presión y la deformación. Bueno, el esfuerzo de formación, perdón. So, the extended leak-off test es como básicamente la anterior, pero siendo una prueba extendida, o sea que se va a repetir las veces que sean necesarios para realizar esta prueba. To this, we have that the extended leak-off point test it's also served to provide the well integrity methods of choice to consider conduction. For example, this leak-off test provides the maximum static mode weight that it can be used. Therefore, before the mode loss results to the hydraulic fracturing of the weakest formation exposed in the wellbore at the time of the test. Okay, so here we are. Estamos siguiendo la pendiente de la prueba de goteo, the leak of pressure, and it's supposed to be in this trend line, but we in some point we have that the formation it's gonna break down, okay, and when it break down the drilling mode it's gonna escape because here we have generated a fracture, so it's gonna escape. So that is why we have this system this lost, okay, so this is where the fracture is going to propagate. Here we have that the fracture is propagation, having a propagation, and suddenly we have a shut-in pressure, so the fracture finally it's gonna close here, okay, so this is gonna repeat, and it also can have 3 proofs more, okay, and for all of this, okay, this figure before we have illustrate the pressure pour, the mood weight, and the fracture pressure. When we are making a design of a casing, we get by different, o sea que necesitamos de la presión de poro, la presión de fractura para modelar la densidad de lodo, o sea, requerida para generar los asentamientos de la tubería, ¿ok? Y pues para esto corremos bajo ciertas condiciones que luego las platicaré, ahorita no, pero bajo estas condiciones de máxima densidad de lodo o de efecto de brote, son las que se utilizan para generar el diseño de las tuberías de revestimiento. So, to talk about some of these types of casing, we're going to have requirements and condition that I was saying that it's gonna be o sea que estos tipos de tubería van a ser con respecto a diferentes casos. Por ejemplo, una tubería conductora pues es la que se tiene que poner a los primeros metros. La tubería superficial es la que nos va a ayudar a controlar de una mejor forma los brotes, porque la tubería conductora no hace eso. La intermedia, que es la que va a estar en función de las presiones que estábamos platicando anteriormente, que es las que tenemos que procurar evitar. Y la liner, que es una tubería que va desde en medio, porque todas estas van hasta superficie, ¿ok? Un liner básicamente puede ir desde la mitad o más abajo de la tubería anterior para ahorrarnos en costos, y la de producción, que es la que ya entra en la zona productora. So the conductor casing, it's the casing that it's in the outer casing set in the well, okay? So it is they have a large diameter, and it's installed to prevent the sides of the bottom hole from caving in. The conductor casing is not gonna be typically cemented in a place, and is used to support the well of the drilling rig, okay? The surface casing is the casing that is set below the shallow unconsolidated formation, and it's cemented into place to protect freshwater aquifers from the contamination and to prevent blowouts, and it provides the structural integrity to the upper part of the wellbore. The intermediate casing is set below the surface casing and to the production casing, and it's used to insulate and protect formation varying the pressure and the stability characteristics, and it also is cemented in places to provide wellbore integrity, okay? The production casing, it's the casing that it's run to the total depth for the well, and it's used for the production of oil or gas. And also I think that the liner, it also can be a production casing. Instead, we use this to para ahorrar pues sí, en el diseño. So the liner casing, in some wells, how I was saying, the liner is used instead of the full casing string. The liners are gonna be shorter sections of the casing that are hang up of the bottom of the previous casing string. So they are typically used to extend casing to a specific depth without running a full casing string to the surface. So here I put some of these purposes of each casing so you can read it. They are a little bit more specific so that it could be everything. So thank you.